All right, so we were trying to figure out u for these, but you may have struggled on this one, because if you make u x squared plus 1, du is 2x. Do I have 2x in the problem? No. But do I have the variable portion of that in the problem? Do I have the x? Yeah. Remember, constants, if you want, can always be thrown where with the antiderivative? Constants can be thrown out front if you want them. So let's try this one. If u is x squared plus 1, the derivative of that, I 100% agree, would be 2x dx. The x portion we have, it's right there. We don't have the 2. So, move it. Well, that's kind of what we do. We make a 2. But if you basically multiply by a 2 on the inside, you have to multiply also by a half, so it cancels out. Okay, so here's how I deal with it. It is kind of like making a 2. Let's divide by a 2. Does it now say what I needed to say? Does it now say x dx? The reason I do it this way, because actually what happens is the book actually does it exactly the way Logan says, is you make a 2. You put a 2 in there, but then you also have to multiply by 1/2 out front. So all I do is I say, let's just take the half. Does everybody see the 1/2 that I'm referring to? Okay. And what I say is, why don't we just throw that out front and get it out of the way? Okay. So here we go. The x dx, which is right here now, gets replaced with 1/2 du. Do you agree with that? And here's always how I write it, and you're going to get really good at this. I know it's your first time doing it. 1/2 du. Because remember, you can throw constants out front if you want. It saves you time a lot of times. How about this x squared plus 1? That's u, but I better make sure I have it squared. Again, have we basically manipulated this problem to get to something we can integrate? That's exactly what we did. Okay, now, are all problems going to set up this perfect where the derivative's sitting right there for you? Unfortunately, no. But for right now, if they're going to give them to us, might as well do it. So when you actually do it, what I normally do is I say, okay, 1/2, and then I just put a parenthesis and say, let's take the antiderivative now. Well, we've already done that one today. It's u to the 3rd over 3 plus a constant. Then there's always the question, should the 1/2 be distributed to the constant? Remember, constants are just constants. Just leave it there. Just leave it a c. Don't all of a sudden have 2c and half c. Just leave it as a constant. And so the, I guess, simplified version of this answer is x squared plus 1 in parentheses till what power? Yep, the 3rd. It's right here. I'm replacing u over 6 plus a constant. And if you remember, radicals caused a problem with derivative. Well, no surprise they cause a problem with antiderivatives too. Some people like to just rewrite it without even trying substitution first to see if it'll help. I think we all know we could do that if we wanted to. Because some people like to see that power. Kind of like in chain rule, you kind of like to see that power. Really, we're kind of limited as what we can choose for u on this one. Yeah, that'd be a dx at that point. We haven't done any substitution yet. We're kind of limited. We kind of have to set it. It's not plus 1, though. What's du? 2 dx. Do I have the 2 that this one down here is referring to? Do I have a 2 up in the problem? Yes, but this much has already been substituted for. So once again, we have to get rid of the 2. How are we going to do it? Divide by 2. Divide by 2. Okay, because there's the dx I need sitting right here. So everything up there should be substituted for, at least the major stuff. Powers don't necessarily have to be substituted for. So the 2x minus 1 can get replaced with u, and then to the 1/2. And dx gets replaced with, so here's dx. dx is, again, 1/2 du. So and so we got a 1/2 just sitting right there, and then it's u to the 3/2. Very good. And then you have to divide by 3/2. So yeah, we've turned it into 2/3. If I were you, I would probably just do that. Cross off the 2's because they do cancel in this case. And then all you have to do is clean it back up a little bit, which is put u back in. So 2x minus 1 to the 3/2 power, all divided by 3 plus a constant. And if you really want to know, you could take the derivative of that using chain rule and see if you get back to the square root of 2x minus 1, or you could just believe me. Again, these are called indefinite integrals because it's not saying from, say, 1 to 2 or 3 to 4. It's just saying find the antiderivative. So that means that this, what we just circled in red, if I take the derivative, no matter what that constant is, I will get back to the original. Okay. Any questions? Okay. The biggest thing to get is the variable part of that derivative has to be in the problem. The constant we can deal with. We did it in the last 2 problems. Okay, but the variable part has to be there. If it's not, this is not the method to be used. Okay.